Hello guys, I hope you all are fine. I'm back again with a new video on actuating methods of soft robots. Yesterday we have discussed humidity actuating soft robots, thermal actuating soft robots, pH actuating soft robots, and the respective diagram representation of these soft robots. Today I'll tell you about a few more actuating soft robots and will show you the diagram representation of these soft robots too. Clear? So topics to be discussed in this video. We will discuss number one, magnetic actuating soft robots. Secondly, we will discuss electrically induced ion migration soft robots. Next, we have dielectric elastomer based soft robots. Then Joule heating actuated soft robots. And in the end, we will see the diagram representation of actuating soft robots. So these are the topics we will discuss today. Understood? So number one is magnetic actuating soft robots. So the name itself suggests it uses the magnetic field, the magnetic alignment in the deforming of soft robots. So under the action of magnetic field, what happens? The size and the direction of soft robots will be aligned in the form of in the magnetic field, in the direction of magnetic field. Clear? So what happens to the soft robots? It bends, it elongates, or it contracts according to the direction of magnetic field, and finally the structure is deformed. Next. So, if we see the limitations of actuating soft robots, we can see the external power sources and the additional wires. So, except these, the magnetic soft robots can even be operated in different mediums like vacuum, air, and liquids. Next, we know the researchers who propose the compliant soft robot and the soft robot with a multimodal locomotion, and it provides on-demand drug delivery applications. Means we can get the drugs on demand instantly, and the soft robots which delivers the drug on demand consists of a body and anterior and posterior legs. And these legs are embedded with magnetic materials having only 3 degrees of freedom. Additionally, we can see the robot has a reservoir inside it which can be used to store drugs, and the drugs are released when it reaches the goal, and the load weight could reach 13 times of the weight of the robot. Clear? Then we have one more example. The researchers proposed a 3D printed magnetic driving soft actuators. We can say DLP. And it has the ability to bend, to deform, and to transport the cargo, etc. Means it can be deformed and do its functions accordingly. Next, we have researchers have also reported one soft robot, which is a sea anemone inspired soft robot, and the soft robot consists of tentacles like magneto-electric sensors. And we can see the magneto-stimulated shrinkable hollow body, which can be protected, and the robot can be protected from being swept away. Clear? So the robot can sense the speed of water. When the soft robot is under the water, it can sense the speed, and it can turn on or off the magnetic field. Whatever instructions are being given to them according to external magnetic field, this robot turn the speed of water to turn off the magnetic field, and it senses the speed of water correspondingly, and it can control the shrinkage and the recovery of the body of soft robots. Clear? Last, we have one more researcher presented a soft continuum robot, and this robot uh, can perform steering. Means it can move in any direction. In omnidirectional means in multiple directions, and it navigate via the presence of magnetic field under the alignment of magnetic field. Understood? Then we have electrically induced ion migration soft robots. So the mechanism of this electrically induced soft robots, it consists of one ionically conducive electrolyte, and this conductive electrolyte is between two electrically conductive electrodes, means two electrically conductive electrodes are on the left and right, and this ionically conductive electrolyte is in the center, and the cations and anions are distributed accordingly, and when the voltage is applied, the structure bends accordingly. Okay. Then we have, I will show you the picture. In this picture, we will see in 3A part that the researchers have prepared a gripper, we can say the soft robots, electrically induced and migration soft robots, and it could do the task based on FCPC PPY IL membrane. And this gripper is under the electrical stimulus. Clear? The cation we can see EM IN plus and the anion BF4 minus, and it bends to the anode. Clear? Then we have one more thing, the researchers made a 3D printed electrolyte hydrogel, which is called as EAH, electroactive hydrogel. And the soft robots that can grip an object, they can hold an object and they can move in two directions of the human, like EAH structure, electroactive hydrogel structure in the presence of electric field. Clear? Understood? Next we have dielectric elastomer based soft robots. So what is the working principle of dielectric elastomer based soft robots? So when the voltage is applied, the elastomer or the soft robot changes its shape and size, and it responds to the external stimulus. So what is external? What is the material used? Dielectric elastomer. So researchers also presented a force sensor by the dielectric elastomers, and it displayed the varied force, and according to the whatever the changes in the capacity of the structure, means the changed capacity of the structure, and it possess enhanced tunable sensitivity. Clear? Then we have the researchers also presented a soft robots which is made of dielectric elastomer, and it is having a velocity of 0.02 body length per second, and it was actuated by the expansion and contraction of the soft robotic body. Clear? Then we have, I will show you the picture in figure 3C. You can see that a soft bionic fish by dielectric elastomers which swims according to the periodic deform of the body, means if the body deforms, it swims accordingly. And the maximum velocity of the fish, what is the fish? The fish is the dielectric elastomer based soft robots, and it is having the maximum velocity of 337.2 millimeter per second, which was about only 0.25 times of its body. Understood? Then we have Joule heating actuated soft robots. So Joule, what is the whose unit is Joule? Heat. Clear? So Joule heating actuated soft robots belong to the thermal driven type. That means this soft robots, if we supply the electrical energy, it will convert it into heat energy and the robot will work. Like how does the robot work? It will change its shape directly, and the most commonly used material in making the Joule heating actuated soft robots is shape memory alloy, that is SMA. So the basic function of this soft robot, it converts the electrical energy into heat energy, and the robot will work accordingly. That means it changes its shape, it deforms its body. Next we have researchers. On the basis of this principle, the researchers have designed a bionic soft tongue which could fetch solids or liquids. Clear? And the contraction or the curling of the tongue depends on SMA material, shape memory alloy material. For example, we can say vertical or horizontal. So how much time does it take? It took about only 2 seconds for the tongue tip to curl the gripped objects, and the currents under the value, what is the value of current? 0.57 amperes and 0.73 amperes. Clear? Then we have They also, researchers also proposed a suit type wearable robot, which is STWR, which used an SMA based fabric muscle as the actuator, SFM. Okay, clear? And the response experiments of the SFM that lifted bar balls. So it find out that the compared to the 2 kg target, the 4 kg target consumed less time. Next we have. So here is the diagram representation of the electrically induced soft robots. Number one, we have this diagram of electrically induced ion migration soft robots. You can see in the part number 8. I told you that in electrically induced ion migration robot, there is one inductive electrode in between, and at the left and right, two electrodes are there, and the cations and anions are distributed accordingly. Next, in the B part, we have tendrils of robot. Then I told you about the fish working. In D part, you can see the active fiber forming process. In next part, you can see the electrochromic principle. And in the last part, you can see the pre-FF-SPR climbs a 12-degree slope and it moves or falls from a high platform. Clear? I hope you understood it. And this is enough for today. I'll be back with some more videos of research articles. Till then, stay tuned to my YouTube channel and please don't forget to like, share and subscribe. Thank you. Have a nice day.